It's my pleasure to be here to share my thoughts on the cooling. Actually, the third year I've been here at Mining Disrupt. What happened during the past 3 years, or even during the past year? So I think the best thing is the boom of AI. So obviously, everyone is talking AI at a mining event. But what happened? Actually, previously, before this, the 2 years, from 3 years ago when we started, the heat from traditional servers, traditional data centers, are not so much per slot or per server. There's only 1 to 2 kilowatts, or even more, but no more than 3 kilowatts. But after large language model, after AI came to us last year, so the output, the heat output per server come to nearly 5 to 10 kilowatts. So it's just like mining machines, right? Or even more. But the problem is it has a higher regional density for the thermal side. And the other thing is it has various heat sources. It's not like the mining machines. So we got nearly 300 or even more chips, 100 chips in one hash board, or 300 in one machine. But for GPU, one single chip can generate more than 1 kilowatt. So for regional heat, it's even higher than the Bitcoin miners. And at the same time, it's so complicated that we have new challenges like the signal integrity issues or some others other than in the mining industry. You may have the question that why computing density matters, why it's so important, why we want to integrate more computing power in a limited space. So it's not the greatest benefit is not to save the space, but to reduce the internal signal transmission distances. That will enhance greatly the system performance. That's the most important reason. When we compare AI computing with blockchain computing, what's the differences? There are a lot of differences, but among them, first, I think actually GPUs, AI computing, is just like ASIC. So it's not traditional GPU computing, like rendering or gaming. It's essentially ASIC. Obviously, the GPU chip is not ASIC, but finally, no one uses it to do other things, only for AI computing. And it's always seek for peak utilization, always 100%, even overclocked. It's just like mining, right? To get a higher revenue. It aims at rapid development and operation. No one wants to wait for 2 years of the infrastructure construction of data center, right? You want to get the compute power very rapidly, even in 2 months, just like mining. And there's more downtime. It's tolerant. So it's not like a web server. Even 1 second it's not allowed. So, and the last thing is the return of investment calculation is just similar to mining. So there's a lot of similar things between AI computing and crypto mining. So that's my conclusion, is that AI computing is more like mining rather than traditional computing. That is a transition on the computing side. As I was a professor in computer science for 19 years before entering this industry, I can see the real transition. Every 10 years, the computing characteristics will be different every 10 or 20 years. So here, we're facing another transition. And the competition is coming. First, for the advanced chip processes, like 3 to 1 nanometers. And they are competing in energy. So a lot of data centers now is finding energy previously used for crypto mining. And they share a common challenge in cooling. So now liquid cooling is becoming default in the next generation computing. And eventually, I think at the end of the day, they will emerge. They will merge finally in the upcoming years. So let's talk about cooling. So I have only 3 minutes to go. So let's talk about cooling. So there are quite a few different technologies, like some we are familiar with. Like hydro. In data center area, it's called D2C or DLC, direct to chip. So it comes from the traditional data center area. And it makes, it's suitable for utilizing conventional server rooms, the data center buildings, to do the D2C cooling. But the big challenge is how to manage multiple heat sources. Actually, liquid only do the 70% of the total cooling, and another 30% is still air cooling. So it narrows its utilization. And single-phase immersion cooling, it offers unified cooling for multiple heat sources, and it has the capability of rapid deployment in even harsh environments, just like Bitcoin mining. So we have many more choices if we use this technology to isolate air, totally isolate air from the servers. And we have two-phase immersion cooling. It's superior than any other cooling methods, but it also has disadvantages on the the cavitation effect from bubble formation and collapse. So it will damage the equipment in the long term. And I think from now on, maybe 3 to 5 years from today, two-phase immersion cooling will be the next very important. But currently, I don't think it's the best time to utilize it in a large scale. And there are some other ways, like a hybrid, to combine D2C and immersion together. But it's more complex, and it has a higher cost. And we'll combine the advantages and the disadvantages of both. So there's no, in summary, there's no silver bullet. So each has its pros and cons. But liquid cooling in the mining industry has been more aggressively used in the past 3 years. I mean, in the mining industry. So that's a good experience and best practices to be applied to AI computing sector. That's what the industry, the crypto mining industry, can bring to the traditional data server industry. So cooling, in the future, cooling is not just for cooling. That is my predict. So what it is about. And what liquid cooling will bring to the industry. So I think the most important thing is it will provide a new way to make a new infrastructure construction model. The basic logic will be changed because liquid cooling can provide when you use liquid cooling, you can deploy any kind of computing power to harsh environments where energy is not an issue, right? So with liquid cooling, the transition of the computing infrastructure building logic is coming. So our mission from our company is to make computing more efficient, more robust, and more economical. So that's why we are not just providing solutions for the mining industry, but also we are delivering the world's first large-scale immersed H100 projects in the coming months. I mean, in a month. So not today, but later we will announce our big progress cooperated with Shell for the world's first large-scale immersed H100 project. Yeah, that's the last page. So we provide all the full stack liquid cooling products and solutions to the both of the mining and the computing industry. And we do customization, long-term services for each customer. We got all-in-one solution with hardware and software integration, not only to solve the cooling problem, but also to promote the computing power at the same time, utilizing cooling technology. Currently, yeah, this project is a very big challenge for us, but I believe we can do it good. Okay, thanks so much. Thank you for listening.